Good morning everyone. Today we discuss about the equipotential surface. What do you mean by equi? Equi means equal potential on the surface. तो definition क्या होगी? A surface having constant potential is known as equipotential surface. Means suppose we take here a positive charge and this is known as equipotential surface. Means on the surface at each and every point the potential is constant. We have here taken as 30 volt, means here every point that is the same potential, that is 30 volt. Okay, so this is the equipotential surface. So what are the properties of equipotential surface? In the electric field chapter we have discussed about the properties of electric field lines. So here we are discussing the properties of equipotential surfaces. So first property is no work done in moving a test charge from one point to another point over equipotential surface. We know that the potential V is equal to W upon delta W upon Q0. So potential VA minus VB. So if at this point A point and B point same potential is there, means here V equal to VB, so delta W equal to 0. That's why no work is done in moving a test charge from one point to another point. A से B पे लाने के लिए आपको कोई वर्क डन नहीं करना पड़ेगा. इक्विपोटेंशियल पे कोई भी पॉइंट पे आप यहाँ पे कोई भी पॉइंट को चार्ज को टेस्ट चार्ज को बाहर से यहाँ पे यहाँ से यहाँ ले जाने के लिए कोई भी जगह पे ले जाने के लिए कोई वर्क डन नहीं करना पड़ेगा. दैट इज द फर्स्ट प्रॉपर्टी ऑफ इक्विपोटेंशियल सरफेस. सेकेंड, इलेक्ट्रिक फील्ड इज ऑलवेज नॉर्मल और परपेंडिकुलर टू द इक्विपोटेंशियल सरफेस. हियर this is the electric field line that is perpendicular. Here it makes an angle 90 degree with respect to this equipotential surface. Equipotential surface tells about the direction of electric field. So it is in the direction of decreasing potential. Here 30 volt is there, here 20 volt is there. On this surface everywhere there is a 20 volt potential, equal potential. Here there is a 30 volt potential. If we move a charge from here to here, then we have to do the work. But here from A to B, no work is done because at the same point potential is same. So if we want to move a charge from one equipotential surface to another equipotential surface, then we have to do the work because there is a potential difference is there. But on the surface, if we move or any point, then no work is done. So that is the first property. And electric field is always perpendicular to the equipotential surface. These are the equipotential dot. It is represented by dotted line for a single positive point charge. So we discuss later on. So that is the second property. And spacing between equipotential surface, this is the spacing. Spacing between equipotential surface defines the strong electric field and weak electric field. If the space is very narrow, all equipotential surfaces crowded, then electric field is strong. And if the equipotential surfaces are far away from each other, then electric field is weak. So that is the third property of the equipotential surface. And last one, two equipotential surface never intersect with each other, as like electric field never intersect with each other. So they make a two tangent at one point and there are two directions are there. So it is not possible that two equipotential surfaces never intersect with each other. That is the fourth property. These are the properties of equipotential surface. Now we see the for different type of charge, the potential equipotential surface having different shape. So for single isolated point charge, the equipotential surface is spherical. Here that is the one equipotential surface. This is the second equipotential surface. These are the equipotential surface for single positive isolated point charge. Now we see for uniform electric field. You know that electric field is uniform. That is, uniform electric field is represented by parallel lines. You know that. electric field is uniform, then it is represented by parallel lines. This is uniform electric field. But what is the equipotential surface? It is represented by a plane. It is represented by a plane. This is first equipotential surface, this is second. Distance between two equipotential surface defines the strongness or weakness of the electric field. So for uniform electric field, it is a plane type, and electric field lines are perpendicular to this equipotential surface. And for non-uniform electric field, it is like curvature. It is like curved surface. This is 30 volt, 20 volt, 10 volt, 5 volt. So the direction of electric field is in this direction. It is in the decreasing potential, towards the decreasing potential and perpendicular to the surface. These are the cases for equipotential surfaces. Now this topic is over. Thank you very much.